calculating probability, new section. Alright, so what's the probability means? Probability means a numerical, okay, something number, numerical measure, like who to the specific event will occur. Anyway, numerical numbers, right? Numerical measure. Alright, two property of probability. So first of all, probability should be always between 0 to 1. Okay, so 0 means nothing, no, the 1 is 100%. okay, so 0 means 0%, 1 is 100%. okay, everything, total number will be total event occurred, the 1 is nothing event occurred, is 0. Okay, understand? Next one. So between the, alright, mention one more time. So like that. So should be event between 0 to 1. Always 0 to 1. Okay. Never. E means simple, A is compound. We're talking about previous one. Alright, so impossible event. Impossible event means never happen. Cannot. So 0 probability. Like 0. Alright, 0. Okay, and next one, sure event. Sure event means occurred, probability equal 1, like 100%, always happen. Alright, occurred. Okay, so probability between 0 to 1. Alright, 0 to 1, always 0 to 1. Next one, the sum of probability or simple event. And experiment denote here like sigma, so all together like here. So all simple event, right? Event all together is 1. Okay, all event together. So event all together means 1. Okay. So for example, like if coin, toss the one coin, we have head, tail, 0.5 make the 1. Alright, okay, and with two coin what happened? HH, HT, TH, HH, head tail, right? Total 1. 0.25, something going on, right? Like that. How about the game, football game too? So win, loss, tie, don't make the 1. Anyway, probability always what? 0 to 1. Remember, okay? Alright, next one. Next one, we're gonna talk about, three conceptual approach. So three concept. The probability, three different probability, the name. Okay, so name, first of all, classic. We done how many percent, right? Probability, how many probability, not percent, how many probability. The relative frequency concept probability, and the subject probability concept. Okay, three things difference. So we're gonna deal with it one by one. The first one, classical probability, which means like number, likely, equally likely outcome, the event, equally likely event, which means two or more outcome have same probability occurrence, let's say. So like, so according to classic probability rule, we have, so like probability simple event equal to 1 divided by total number. So what's happened, like head, tail, how many, if you toss the coin, how many head? 1. Total event 2, right? So 0.5, something like that. Okay, alright, compound event, so more than 1, right, equal to number of favorable event. So like even number, odd number, even die, toss that, how many even number? 2, 4, 6, right? Total 3. compound event, right? Total is 6, so 0.5 anyway. Okay, so compound event, so favorable event all together define total number. Okay, so simple event, numerator, which means 1, like unit fraction. Compound is different. Okay, so about here, so simple event always numerator 1 because 1 event in the total number, and the compound event is different. The favorable, so it can be 1 or almost total, yeah, depend on. So how many number of outcome will be same conditions satisfy, so favorable A. Okay, all right, so maybe we look at some example. We're talking about simple event. Okay, so found the probability obtained head and probability obtained the tail, like coin and tail. So how many outcome? Should be 2 outcome, head, tail. So equally likely outcome, right? Chance the same 50-50. So how can you calculate? Head, 1 head, total number, right? So simple event always numerator 1, denominator total number. Similarly, tail 2, 1 and outcome the total number 1/2, so 0.5. Okay. Yeah, how about other example? This time compound event. Okay, so more than 1 usually. So probability obtain event number, roll die. So event number, should be even number, sorry, should be even number. So 6 outcome, 1/6 likely, equally likely, right? So a event, even number obtained that the events are even number. So here 2/6. Okay, so even number, right? Even number 2/6, right? So even number 2/6, right? Odd number 1/5. Okay, so sample size, sample space, like that, right? So one of these number obtain a event A occur. So how can you find it? A, even number, right? So number of favorable, so number of outcome include A. So how many here? 3. And total number 6.5. Okay, I think it's not hard, right? You got a kind of common sense there, right? Alright, next one. So calculate one more compound event. So 500 women in the group, so 80 play golf at least once. So suppose one of them, 500 women, randomly select. What's the probability she played the golf at least once? Okay, that means here 500 women and here A play golf at least one. So they select from here. Okay, and how much the probability? So because select all the randomly, each of 500 women, the same probability being select. So they have a same chance to select. So experiment total 500 equally likely. Okay, this one also equally likely, like die or coin, equally likely outcome. Okay, so here you go, 8 of 500 outcomes, total 8. So maybe they have a chance to 80 people, 80 women out of 500. So satisfy to play the at least once. So hence event A is select woman has played golf at least one. How many people? 80 people. out of 500. So 0.16. Okay, it's a compound event. So how many people? 80. So simple event should be 1. Okay. So before classical event, probability. Second one, relative frequency, concept probability. Relative frequency. Okay. So suppose we calculate following the probability. First kind of example, probability next car come out of the auto factory is lemon out of. And second, randomly select family, own and home. Somebody doesn't, somebody has, right? And randomly select woman has never smoked. Alright, 80 years old person will live at least 1 more year. Oh, okay. And toss the unbalanced coin. Result is a head. Unbalanced coin. Okay, and then select the person on sports utility vehicle SUV. Okay. So probability cannot compute. This one is hard to compute. So using classic probability rule, because variable various the outcome, he recommend corresponding experiment not equally likely. Do you understand that? So classic have the equally likely. This one not equally likely. Not equally likely. Okay. So relative frequency event, approximation probability and event. So in this case we can say approximately get some number, not exact number. So only classic probability means equally likely, right? Equally likely. So exact number. But relative frequency is only approximation. Okay, the exact number. Okay, that's different. The number have come out using classic probability. We can find the exact number. Okay, but in this case, relative frequency or approximation or too big or not sure, depend on case by case. Okay, so consider large population with a large number. Relative frequency will be exact probability. For example, if you toss the coin, toss the maybe coin, okay. So you maybe only toss the twice. So head. So you can say when you toss the coin, always head. Can you say that? It can be, but if you try maybe 1,000 times, that time about maybe 0.5%, 5% maybe, right? And try. So which means large number try can be exact number, exact probability. But small number, just couple try, not really, just approximation. Okay. So hiding someone. So anyway, here, let me write this part. You have to see. Sorry about that. Like here. Okay. So here you go. So using relative frequency approximation probability experiment. So repeat n time. So event A observed f time. So according to relative frequency concept, like here, okay, f over n. So we may have example. So what kind of relative frequency question, like a simple data. So 10 of 500 randomly select car manufacturers, certain auto factory has found the lemon. So assume lemon are manufactured randomly. So what's the probability? Next car manufacturer at the auto factory at lemon. So we have an anti-note. So denote means total number of car. F means number of lemon. So N 500, F is 10. Like here, to make example, good car 500, 409 is good, 10 is not good. So relative frequency, right? We already know, right? So how can you calculate here? Kind of relative frequency table or relative frequency. So 10 is problem which lemon, so 500 total. So what's the probability relative frequency of the probability? Just like that. Okay. So OIP1 make the table we done before, right? So depend on question. Okay. So simply how many problem out of total number. So kind of approximation to large number. In this case, kind of large numbers. So maybe it's almost right, almost exact number, close to exact number. Yeah. All right. So frequency, relative frequency column. You know frequency table we made a million times before. All right. So like that. Okay. So lemon is 0.2, which means 2%, 98, which means 98% total. So relative frequency are not probability, but approximate probability. You know what I'm saying? Not accurate, not exactly, but close to, almost approximately. Okay. So if you have law of large number, we mentioned that if large number is close to exact number, so experiment repeat again. The probability event occurred from relative frequency approach actual or theoretical probability. Okay, so which means it's number of try, large of try number of large number was this large sample, right? That time we can say it can be actual number or close number, almost that number, we can say that, but it's not. No, just approximation. Okay. All right, example one more. So approximation, probability, relative frequency question. So let's say, so have probability and random selected family from New York own home. How can she determine this probability? So how can she say determine this probability is okay? So you have two outcomes because they're asking own house or not, right? So the question is own house or does not, right? Not equal likely. Of course, it's not equal likely. Okay. Only guess approximation. So classic probability, probability, this can apply because it's not exact number. Okay. But we can repeat the experiment again. So if you try many people, it's close there. So relative frequency approach to probability. So they approach to close to exact number. Okay. So suppose here sample size. Okay. Random sample 1,000 families. Good. The New York observe 670 have their own home, and 330 does not. That time, repeat one more time. Sample size 1,000, and number of have own home 670. Okay, and we ask you how we can she determine the own home. So here, total number and whatever they say that satisfy the condition. All right, so 0.6670. Okay, so note 0.670 is just approximation probability randomly selected family from New York. So you can see the approximation randomly select. Okay, get it? All right. So sample size. So sample size is pretty big. So variation expected very small, which means closer or actual number, closer, much closer. Okay. Okay, next one. Subject probability, little different. This one, experiment neither have what's that? Equally likely occurred, no repeat. So we explain two classic or classic probability and relative frequency is not totally different. Okay, not equally likely, repeat is not. Okay, so this one search cannot compute the probability event using classic or relative. Not compute, which is not number. Okay, so consider some example. So car taking statistic, he got the A. Do you know that he got the A? We don't know. Maybe. Also, industrial average higher than end of trading? We don't know. Maybe. How about here? Miami Dolphin will won sports ball next season, like football game. No, they may not. Luckily again. Or Jonas lawsuit filed against Landro. Not sure. Okay, because not exact number, the guess. Maybe he's good. So subject to probability assign event based on the subject, which a subjective judgment, experiments, information, or belief. Okay, subjective judgment or experience, information, belief. There's no data. Okay, so arbitrary. Yeah, it's not conform, right? Okay. So influenced by bias, preference, experience, person, assigned probability. Okay. So depend on person anyway. So not clearly used. Just we can say it may be possible, just subjective probability. Alright? So we're talking about three things. Remember, classic probability, relative frequency probability, or subjective probability. You should distinguish three things. Alright? Alright, see you next time. Or don't forget that Thursday we have the class. So if you have a question, bring up. We can discuss about that. Alright? Okay, thank you. Bye bye.